A world model just outran an MTP-enabled coding model on a local GPU across an 11 prompt set with a large context window. That is interesting, because Qwen Agentworld was not built as another general chat model, and it still beat a faster decoding path. Agentworld is Qwen's language world model for predicting what an agent will see after it takes an action. It is designed to simulate evolving terminal and code-based states with tools and search, plus browser pages, desktop systems, and Android. Qwen3.6 is the familiar general-purpose coding and tool use model. So this test asks how a specialized world model behaves as a local deployment. Both models are 35 billion parameter mixture of experts designs with 3 billion active parameters per token. They ran as matched Unsloth dynamic 2.04-bit GGUFs on the same Ryzen 7 and RTX 4070 Ti superhost. The server held a 98,304 token context with flash attention and Q80 key and value caches. Each request used the same 256 token completion target, while inputs ranged from 30 to 77,376 tokens. The Qwen3.6 baseline also had multi-token prediction switched on with up to 4 draft tokens. This was not an MTP file running in ordinary mode because it drafted 3,158 tokens and accepted 2,005. Its 63.49% draft-weighted acceptance rate makes it a serious speed baseline rather than an easy target. Even with that advantage, Agentworld averaged 60.63 tokens per second against 55.61 for Qwen3.6 MTP. It won 8 of the 11 generation measurements and delivered a 9.03% average lead. The bigger surprise was prompt processing, where Agentworld reached 720.9 tokens per second, while the MTP run reached 545.9. That is a 32.06% advantage before either model starts producing its answer. Multi-token prediction still showed why it belongs in this comparison, because it delivered the fastest individual completion. On the 1,677 token prompt, Qwen3.6 reached 68.59 tokens per second with 86.03% draft acceptance. It also won the 2 medium context measurements, but Agentworld still held the average lead against working speculative decoding. The useful finding is that Agentworld was especially quick at getting through the prompt before either model started producing its answer. That speed result becomes more interesting once you look at what Agentworld is meant to do. Qwen trained it as a native world model that predicts the next environment state from an agent action and its interaction history. The published model supports 7 domains, including terminal simulation and software engineering with MCP tools, and search plus web, operating systems, and Android. On Qwen's Agentworld bench, it reports a 56.39 overall simulation score at this 35 billion scale, which gives the local result some context beyond a random new checkpoint. Memory is close enough to call a wash for this class of model, and it should not drive the buying decision. Agentworld recorded 12,766 mebibytes, and Qwen3.6 MTP recorded 11,812. That is a difference of 954 mebibytes, while both selected GGUF files sit around 18 gigabytes. The practical result is that Agentworld buys its throughput lead without demanding a radically different local hardware tier. The headline is not a replacement story because Qwen3.6 remains the general coding agent with a strong MTP path when draft acceptance is high. Agentworld brings a distinct environment simulation role, and this local run shows it can win a speed test as well. For anyone building local agents that need to predict what a terminal, browser, tool server, or desktop will do next, this is a promising result. Agentworld is not merely novel on paper, because this configuration makes it the faster deployment on average. The next test should put that world model role to work inside real multi-step agent trajectories.